Okay, let's take a look at this Sec 2NA question again. It's about the volume that's related to hemisphere, related to a cylinder, as well as a cone. Okay, so they mentioned that the diagram below shows a solid formed by removing a cone and hemisphere from the ends of a cylinder. So you have to visualize that this item is in front of you. It's like a solid made up of material, okay, and then the hemisphere is like a hole. Is it a hole? And then after the cone is also a hole. So what is like the remaining volume, which is the space and amount of the material? So actually you know that, oh, it was going to be the volume of the cylinder minus away the volume of the hemisphere minus away the volume of the cone. So of course we have to know the formula for those shapes that I just mentioned. So let's do it. So usually what I will do is, so I will say volume of the solid, okay, is equals to the volume of the cylinder. I'm going to minus away the hemisphere. I'm going to minus away the cone. So let's find the volume of a cylinder. So volume of a cylinder will be base area times height. So I will put it as base area multiplied by height first. I'm going to minus the volume of the hemisphere. So you see, volume of a full sphere is 4/3 pi r cubed. Hemisphere means it's like cut half. So then you just add a multiply by half. Let's put a bracket. Minus the cone. So cone is actually 1/3. You see, there's a Christmas tree here. So it's actually using the same formula as a cylinder, which is base area times height, but with a 1/3 in front. So I just multiply by 1/3 and then close bracket. So now let's see what is the base area for the shape. So for the cylinder, what's the base area? The base area is a circle. So we apply the area of circle formula, which is pi r squared. Then multiply by the h. Okay, I'll use small h, it doesn't matter. This one will be 4/3 times half will be 2/3. So it's 2/3 pi r cubed minus base area is a circle. So it's pi r squared h multiplied by 1/3. So this will be the formula for the different shapes. Let's plug it in. So let's always check whether they can ask you, oh, find any pi or not. Did they ask you to use any particular pi? So for this case, this number mentioned you to use what pi, so you should use calculator pi. So let's put in pi. This is the diameter 6, so of course the radius is 3. So pi 3 square. The height of the cylinder is 12. Minus 2/3 pi 3 cubed minus pi 3 square h. This is the cone. Cone height is 4. So this one is 4 and then multiply by 1/3 again. So of course, everything going to press the calculator. So of course, calculator gives you 245.044. You always write out the long one. Then after that, you round it off to 3SF. Okay, when it's not exact, you will round off to 3SF. So it's 245 and this is volume, so it's cm cubed. And you are done. So put 3SF this side. So we are done with part A. Now let's take a look at part B. Part B say, okay, calculate the total surface area in cm square of the solid, leaving your answer in terms of pi. So if they say in terms of pi means you don't use calculator pi, just keep it as pi like normal x, like algebra like that. So let's take a look. What is total surface area? So total surface area, same thing. Like I mentioned, you have to visualize that the solid is in front of you, correct? So you visualize that, okay, it's in front of you. You're supposed to paint the surface that you see. You understand? You're supposed to paint the surface that you see. So what are the surfaces that you see? You see, for the hemisphere, you will see an arc inside, right? So let's call a curved surface area. And then for the cylinder, you will see the curved surface area of the cylinder. And then for the bottom denominator, you will see that it is there's a curved surface area of the cone. So there's total only 3 phases. You see the curved surface area of the hemisphere, you see the curved surface area of the cylinder, you see the curved surface area of the cone. So let's find it separately. So for this case, total surface area is, of course, you have 3 phases, so it's addition. So let's find the hemisphere surface area. So for full sphere, it will be 4 pi r squared, right? For whole sphere. Then for hemisphere, is half of it. So I just do a times half. Then let's put a bracket. Plus, then how about the cylinder curved surface area? So you must know that cylinder, when they actually open up, okay, when it actually open up, it's actually a rectangle. Okay, it's actually a rectangle, whereby it is the so-called the length and the breadth that give you area of the rectangle, correct? So in the cylinder, the length of the rectangle, so-called, is the surface area of the circle. And the breadth of the rectangle is actually the height of the cylinder. So it means that it will be just the circumference of the circle, which is pi times diameter, and multiply by the height. Okay, I usually put in the formula first before I put in the numbers. Why? Because in case you put in the wrong number, okay, at least the teacher can maybe say give you some working marks for your math formula. Okay, then after that, we left with the cone. So the cone, you actually only have the curved surface area of the cone. So which is pi RL. Okay, pi RL formula is given during the exam. Even the 4 pi r square is also given. The only not given is, this is not given. So you have to know that when you open up, it's actually a rectangle. So now let's plug in the number. So don't forget that they mentioned they want it in terms of pi. So for pi, this is 3 square multiplied by half plus pi 6 and the h is 12. This is pi, same also 3, and see, we don't have the L, right? So the L you need to find. Let's do it this side. So it's actually a right angle triangle. The height is 4, and we know this is 3. So the L is actually here. So by Pythagoras theorem, we know that L is equal to 3 square plus 4 square, then you square root, you get 5. So the L over here is 5. So key into the calculator and let's see what we get. As in, please take note, you have to take away the, you don't press the pi. So when you key into the calculator, you key in 4 times 3 square times half and you get 18. So it's 18 pi. So you do the same, 72 pi, 15 pi. So in the end, you get 105 pi. And this is cm squared. Done. So we are done with part B as well. So now let's take a look at the last part. Okay, this is not supposed to be C, it's supposed to be D. I mean, supposed to be C, not supposed to be D. So this one's supposed to be C. Okay, let's take a look at part C. I'm going to change another color. They say, okay, now a tube of paint can cover 36 cm square of the surface area of the solid. So how many tubes of the paint are needed to paint the entire solid? Just now you already calculate that, okay, the surface area that I need to paint is 105. So you need to know this, you need to do this calculation, right? Then after that, you go to the shop and then you have to tell the uncle, oh, how much paint you need to buy. So they tell you, oh, and the uncle say, okay, a tube of paint can cover 36 cm square of the surface area. So for yourself, you have to calculate. So you will have to take the surface area that you're supposed to paint, divide by 1 tube, which is 36. Okay, and how many will you get? So you will get 9.1629 tubes. Okay, and again, as I always be saying, when you go, you cannot say that, uncle, can I buy 9.16 tubes? There's no such thing, okay? You got to round up. You can only buy more, you cannot buy less. You buy less, you didn't cover. You cannot say, you know, 偷工减料, like you will paint maybe a few parts that you don't paint. No, you can paint, you can have more, but you cannot have less than that. So of course, you tell uncle that, okay, uncle, I have to buy 10 tubes. Okay, yes, so that's all for this question. And this is easy. Bye-bye.